All right, Katie, what do you think? Should we get started officially?
Yeah, let's do it.
All right. Well, welcome everyone to this breakout session conversation about physical computing, robotics, and Maker Ed. We're so happy that you could join us this morning, and then for this session, I know I've already had a lot of awesome takeaways, and I'm excited to just have a great conversation about this topic with you all. As a reminder, our shared notes for the session can be found on the MNCodes.org website. And then feel free on the session notes document to jot any notes as you see fit or links to resources. Feel free to drop your contact information, and we can connect after this session as well. So we'll just do some quick introductions. You can tell us who you are, where you teach, what grade level or content area, what's your experience as it relates to robotics and physical computing and digital making. To start it off, my name is Rachel Miller. I am located in central Minnesota in the St. Cloud area. I teach 6th through 8th grade technology, and I do technology integration this year. Next year, I'm switching gears to teaching technology and music. At Sartell Middle School. My background is actually in music education, so I spent 5 years as an elementary and a middle school band teacher before kind of switching gears to the technology side of things. So I still do both at my school. I coach middle school Vex Robotics and then high school First Robotics. And last year I helped direct the high school marching band. And then this year I was planning on helping with our middle school marching band, but a lot of the summer activities have got cut short. So my contact information is there if you need anything, but I will turn it over to Katie.
Hi, everybody. My name is Katie Henry. I am the head of partner engagement for North America for the Microbit Educational Foundation, and I get to work with schools all over with physical computing, STEAM education, maker education, and computer science education. So lately on Twitter, I've been celebrating Scratch Month and created a Flappy Birds face tracking game. So if you want a fun project for your students to do at home right now, you can go to my website, katiedays.com, and copy the code. And it actually will create like a push-up game. So Flappy Bird tracks your face, the pipes scroll across the screen, and you have to avoid hitting the pipes using your face. So it's a lot of fun. Yeah, I'm really excited to be here with you today. I have 2 cool things to share with you, and 1 free opportunity for 20 robots are being given away, first come, first serve. And so we'll get to that in a minute.
Andrew is going to get on that, that's for sure. Okay, so let's turn it over. Let's do some other introductions. Feel free to unmute yourself and share whatever you would like to share.
Hi, I'm Jason Bohr. I work at the Computer Science Teachers Association as the chapter relations manager. So I get to see a lot of people all over the country, and it's great. Before that, I was a high school English and computer science teacher for a dozen years or so, teaching CSP, CSA, and exploring computer science. Happy to be here and see everyone and meet everybody. It's been great so far.
Awesome, thanks, Jason.
I'm Cecilia Ressweber, 4th year CS teacher at a K-8 school, 25 years of experience in kindergarten and preschool. So this is sort of like a second career. The only CS teacher in my school and in my district of the Archdiocese of Galveston-Houston. Everybody else is technology teachers, but I focus on CS more than teaching applications. Next school year, hopefully we will actually be in school, and one of my middle school classes has sort of a class within a class, and I'll be doing some physical computing, but I need way more training, and so I'm very excited about this particular breakout. So thank you for sharing your expertise.
Awesome, thanks, Cecilia.
Hi, my name is Kelly Mean from Chilton, Wisconsin. I am a middle school and high school business ed and computer science teacher. I am just trying to get computer science in our rural community.
Thanks, Kelly.
If you want to introduce yourself in the chat, go ahead and do that. We'll take probably just a couple more people that want to introduce themselves over the microphone.
All right. Looks like we've got Kate from St. Paul, Teresa. Thanks everyone for being here. We're just really excited to hear your different, backgrounds, your areas of expertise, and just to kind of engage in a lot of good resource sharing. Anyone else want to speak up on the mic before we kind of move forward? Again, we're just really thankful and excited that you all can be here. It's been such a cool morning so far.
Yeah.
All right, let's jump forward. We're gonna go, and Katie and I were just talking about how about we're gonna use this opportunity to kind of share some of our favorite resources that can be used in distant learning. They might be a little bit more relevant in distant learning, or they can be used beyond distant learning. So I mentioned I'm a robotics coach at the middle school level and high school level, but this Vex Code Vr is a great resource for students to use that doesn't require having an actual robot. So this has been a really, really fun and exciting tool to kind of learn how to use. And I'll show you a little bit of what it looks like. So it uses the platform Vex Code blocks, which looks very, very similar to Scratch blocks. When kids are competing in robotics, they have the option of using Vex Code blocks or Vex Code text. The problem with most students as they engage with robotics during distance learning is that kids don't always have a robot at home. So this is a platform where we can run almost the same code on a virtual robot and see it in action. So I am just shout if you are unable to see my screen. But what happens is you see I have my when started event block and I have my drive forward, and I just need to open up a playground. And it takes a little bit to load, but this website works on computer, but it also is compatible with most tablets. So we can see this grid map here, and I'm able to run my code by playing the code on the playground. So it might be a little glitchy, but you can see that the robot is moving forward. So there's a lot of different opportunities that we can use with Vex Code VR with distance learning, but then I also have every intention to, apologies if you hear the emergency sirens behind me. I have every intention to kind of use this as we move forward into our next season next year with kids. So a really cool resource that I love. Oops, there we are. All right, next up. Okay, are we back to the big screen?
Yes, I see.
Perfect.
I see it.
All right, Katie, do you want to talk a little bit about Microbit Classroom?
Sure. Just quick show of hands, whether using the raise your hand feature in Zoom, or we can raise your hand. How many of you are using Microbit already? Is anybody currently using it or have heard of it? You can also raise your hand if you've heard of it. Okay, awesome. Microbit Classroom is a way to organize and manage a virtual learning classroom when teaching with Microbit. But the cool thing is you don't need a Microbit to use the free tool. So actually, would it be okay if, Rachel, can I just quickly demo the simulation?
Oh, for sure. I'm going to stop the share and you can take over.
Okay, I'm clicking share screen and I'm going to share screen too. All right. Does everybody see a big pink flower?
Yep.
Yes.
Fantastic. Now do you see microbit.org?
Mm-hmm.
Yep.
Great, the internet's working. Can't confirm. Okay, so at microbit.org, if you click on this button, Learn at Home, you will find some really great activities you can just simply assign your students. These are just sort of like optional activities, fun extras. You could tack them on to the end of an assignment. This really was designed for the absolute beginner at home so that a parent would sit down with a child, or a parent might tell the child to go here. So this is really designed for home learning, kind of separate from classroom facilitation. So there are some really neat projects here. You can build them with the simulation. But what I want to share with you right now is using Microbit Classroom. So on our website, you can come to the projects page and choose from 49 projects your students can do without a microbit. And I'm just going to show a very simple introductory activity, but if you notice over here, you can search by Python activities as well. You can search by topic area or even device feature if you want to focus on a specific input and coding it in Python, etc. So the idea though of Microbit Classroom is you can bring your students into a synchronous learning experience and then launch them into asynchronous learning. So for example, this is a great little beating heart activity, and let's say I want to open it in Classroom. So right away it generates a classroom for me. No student login information is needed. Kids can join you now. And if you have a second tab open and want to join this classroom, you can, but I'm just quickly going to go through the demo. I want to teach beating heart today in MakeCode. So I'll select MakeCode. I could also do it in Python. And again, just to show for that data privacy, either you store your students' information on your machine only, or uncheck that box and it's saved nowhere. And all that is saved is a copy of their code with the student name that they typed in at that time. So just like putting a name on a worksheet and handing something in, students will type a name right then. That's what gets saved with their code. Very simple. So once I launch the classroom, I am presented with 4 simple steps. They're the same every time. You start by setting up the classroom itself. And so here the code is already written for this beating heart, but let's say I want to separate it. And now I can right mouse click on any of the blocks and add a comment with some directions. Please create a beating heart animation. After you have done that, try to create your own animation. Submit your assignment when you've created something you love. And now you might also have, depending on where you are in instruction, remember to include an input, remember to include a function, remember, if there's a specific skill you've been emphasizing, you can put that into these instructions as well. But just to continue the demo, now I want to come over here to share this code with students. So now I've just pushed it into the classroom and I come to my dashboard and I invite my students to log in. So if you were to go to microbit.org/join and enter in these 4 characteristics and this PIN number, I would see your name start to appear here and you would be presented with that coding activity. So again, this allows me to virtually peer over students' shoulders. So I could click, like for example, if Rachel logged in, I could click on Rachel's name and I could see how she's coding, what she's coding, how she's doing. Finally, I am able to save the classroom and relaunch a session, in my next class if I want to. But again, that's only if I save the data to my computer. So I'm just gonna actually peek over Andrew's shoulder here. And I can now see that Andrew is in the class. He's working on assembling his beating heart. Dave has logged in. Dave is working, Devin's working, and I can kind of see what my students are doing. Microbit Classroom pairs really well with a tool like Zoom for chatting. It pairs really well with a Google Classroom where students can post in a thread or post comments back and forth to each other. It's a really great tool, works well with other tools you might already be using. Now, just to really make this final point clear, you don't have to create your own lessons. You can launch a lesson from any one of these activities here. 49 lessons ready for remote instruction. Use the simulator. Massive success. I heard a question, I think. Did somebody start to speak up?
I think they were wowing.
Oh, wow. Wow is good.
Yes.
Yeah,
I was
looking
wowing.
at the chat, we've got a comment about it works on the cell phone too, which is really neat.
Yes, absolutely. It will work on mobile devices. So that is a wonderful ability for kids at home that may not have their own Chromebook or desktop. Finally, on the lessons page, you can find full units of instruction. We've just created 12 new units for instruction, again, searching by programming language or subject topic. And where you see this green icon next to a lesson, that is where the microbit, the hands-on component comes into play. And again, you don't need a microbit to do these lessons. The simulator is fully functioning, and these are tons of fun for kids. So let me stop there. And we
Katie, can I ask you a question?
Absolutely.
can the students view other students' work and collaborate together then in this
Yep.
atmosphere?
Yes. When you're in the classroom, in that dashboard view, you can share code between students. So if a student wants to share their own code, they could share a link in the Zoom chat or share a link in the Google Classroom. But the teacher can also, select Rachel, share code with Andrew, and pass Rachel's code to Andrew. And then actually, if you were in Zoom, you could spotlight Rachel and let her talk through her code to whoever she just shared that code with.
Wow. Thank you.
Thank you. This third bullet point here, there's one quick plug. It's in the notes page. This is from cybersecurity experts, Parallax, with their robot Cyberbot. They want to give 20 Cyberbots away and 3 free hours of Python instruction. They just ask that you be a middle school or high school teacher, and you can apply by clicking at that link, and they're turning around notifications pretty quickly. So you will find out in the next, within a week, by mid-May, if you were accepted.
Yeah, and
just want to let you know, chance for a free robot.
Awesome. And these next few bullet points, the Code Savvy CS2Go you heard a little bit about earlier this morning, as well as the Minnesota or MNCodes distance learning resources. So those are links that are available to you as well, focusing on some unplugged activities, some computational thinking, some involving digital making, physical computing. And then this Raspberry Pi digital making at home was a resource I was just made aware of not too long ago. And so looking at it, there are a variety of different options and activity suggestions provided by Raspberry Pi for what students can do in relation to digital making at home. So again, I was just made aware of this resource not too long ago, so I don't have a ton of familiarity with specific activities, but I would encourage you to take a look at it as it relates to your students and as we finish up the rest of the school year with distance learning. Does anyone have any other favorite resources that they've used for distance learning or even throughout the school year that have translated well to distance learning? This would be an awesome opportunity to do some resource sharing if anyone wants to speak up.
I'm curious to know if how physical computing tools are being managed. If any tools have been dispersed to your students, do you have big tubs of tools at school right now? Are you thinking about how to share those over the summer? I'm curious for ways to share tools, if anybody has any examples. And it might not be a bridge that is being crossed yet. I have heard of some districts that are one-to-one who have started asking the question, how can we teach STEM and CS at home with the tools we left in the classroom? Just curious if anybody's asking that question yet.
See, I see a question in the chat from Christine. What would be affordable devices for families to purchase? I believe, so microbits are...
The microbit.
Yeah.
Mm-hmm. To get to the question about distributing materials, I didn't this time with our current distance learning. I have a class of 20 students with 10 EV3s, so they work in teams, so that would not work this time. For unknown reasons, my class for next year is less than 10 students, my robotics class. So if it stays like that, if we start in distance learning, I will distribute those EV3s. But I also have another class that's got a class within a class. So I have about a handful of students, and they'll be buying their own microbits. This year, it was just not possible with a change in numbers next year to continue learning, and hopefully we'll either start with, brick and mortar school or go back and forth. I don't know, but I'll have enough equipment next year at least to get kids hands-on.
Seeing some suggestions about various suppliers. Oh, in Canada, nice. For those of you that do have like a makerspace or have kids that are working in making, what have been some of the workarounds or solutions that you found for engaging kids in those activities at home?
I guess I can talk about that really quick. We've been having kids model the parts at home and send them to us, and we 3D print them and then send them back to the kids. Whereas in the school environment, the kids would be actually like printing their own designs.
Sure.
But we've just had one teacher in the space so that it's, you know, safer and cleaner. And we gave them a specific challenge to look at like modeling and printing PPE, which has been a lot of fun. The kids have really gotten excited about that.
So I have a question, because I have like in the class I teach, which is a class we called Next Generation Skills. It's for a sixth grade class. We do some 3D design and modeling as well. Do you have to give pretty specific like design guidelines or parameters in order to print their designs from like a remote distance?
Yeah, so we worked through a set of scaffolded activities where they first like modeled a part that we had shown them how to model. Then they modeled a part from a drawing, and then they were able to like, since we had them do a series of increasingly difficult tasks, they then got to the part where they could model their own thing. And we do review their designs before they print them. So they share their design file with us as well as the STL, and we kind of iterate and let them know if it looks like the print's going to fail.
Sure. Cool. Thanks for sharing. Okay, we have a question in the chat. Katie, I think you can tackle this one. I have a microbit I need to play with. What is the biggest benefit of using this tool? I think we all have a lot of people, it sounds like, have used microbit, but
It's so fun. That's the biggest benefit. It shows anybody can create with technology. I lately have been obsessed with clipping my microbit to gloves, and Colleen and I from Makey Makey ran a webinar on Tuesday. We had 1,048 people register for the webinar with microbits and Makey Makeys on gloves. And so I actually have my Makey Makey set up over here. I made a little sock puppet with the foil to connect the circuits. So in Scratch, you can do some really fun wireless activities with your microbit. I was making dance games. This is my rabbit, Pete the rabbit. The story behind Pete is that he lost his beat, and so you had to write code to help Pete find his beat. You could change the lights, change the instrument, you could dance with your glove. I think the biggest benefit is just that anybody can create with it with whatever they have. It's really, really fun. But it also has a very high ceiling. So, you know, for those of you that are using it at higher levels, you do know you can do so much more with it. Just a really great way to bring everyone in to creating with technology.
Oh, Kate is chiming in on the chat. Biggest benefit, teaching physical computing concepts without having to introduce circuits and wiring. So I think that's really important if we want to start talking about physical computing getting to younger learners. So I appreciate that comment. Thank you. Does anyone other have any experience or successes with microbit specifically, or a different piece of equipment that they use for physical computing?
I've done some stuff with Makey Makey as well, and it's good to get started as well. So like thinking about circuits and building, not just digitally, but building physically as well. So just like not even having the Makey Makey plugged into the computer, but using it to create a circuit, because when you flip it over, you can get some of those outputs as well. And so that's always fun to explore with as well. And just getting like down and dirty with stuff and creating. So And shout out to Katie. You're rerunning it on Tuesday, right? You're rerunning the session?
Yes, we are rerunning the Makey Makey and Microbit session this Tuesday, and we have all the resources are posted to do the activities at home. Yes, thanks, Andrew. You're all invited.
Awesome. I have some familiarity with Spheros as a tool for physical computing in my class. One of the things that I really like about just this idea, this notion of physical computing, is that kids are coding, but then they're also seeing the result of their code and their program in real life. It's something tangible, and I think that's really important about this idea of digital making in robotics and physical computing, is that you're seeing directly what's happening as a result of the code that you write.
Another device that's really similar to the microbit is the Circuit Playground, and I've had some success with the Circuit Playground Express from Adafruit.
Minecraft education, absolutely. It is the ability to get creative with Minecraft online is through the roof right now. People are gravitating to it like never before. I think there was a Washington Post article about some teachers in Broward County doing really cool things with Microsoft or Minecraft. Does anyone want to speak to Minecraft EDU and how they might be using that right now?
I'm not, but I know that I'm looking to do it. I know there's lots of groups out there doing professional development on a lot of these different platforms right now. And so like attending webinars and like sessions like this and PD opportunities are out the wazoo. Like I don't know how teachers are, well, if teachers are interested in attending those, it's like, hey kids, hold on a second. I got to attend this awesome webinar. But it's, I know that there's been lots of opportunities to learn, and that's something I was like, oh, that'd be cool to see, because, you know, if we also do summer camps, and so I'm thinking, like, if we have to do remote summer camps, like, we have to think of something that will work, and the students, like, they'll play on Minecraft for 12 hours a day anyway, so to be able to link them to a server and, you know, like working collaboratively on something together with some interesting connections would be a fun experience. And I know that and Katie, you probably have seen this, someone connected Minecraft with a microbit. Like there was like in Minecraft, there was a huge microbit, and like, I don't know if they like clicked buttons on Minecraft and it turned on the button on the microbit, but it's like those app smashings, like things that I'm excited about seeing, and just throwing two random objects together, like how does this work and how can we work this together? So yeah.
Exactly. And on that note of bringing two things together, MakeCode just released the beta version of their new editor. So it's just MakeCode beta. And in this new version, there are many cool features, including blocks to Python. So, you know, currently in MakeCode, you have blocks to JavaScript. In the beta version, you now can do blocks to Python, and there's some other neat features, very student-friendly, teacher-friendly features. So definitely check out the new beta MakeCode. Your students can begin using that now as well.
Yeah, I just commented about that. That is one of the things that I love. So we are kind of like an Apple school district, but we have a few PCs that have Minecraft Education Edition, and admittedly this year and last year I just acknowledged that kids love to play it, but I didn't actually like spend a ton of time learning myself about its potential until I happened to buy an Xbox and it came with it, and I was spending some time with the MakeCode tutorials, and I just love being able to switch between the different coding languages, because I think that's a really great thing for kids to see.
Definitely.
All right, we just have a few minutes left already. So I'm just going to flip over to, we have tips and examples, just kind of talking about how we can leverage everyday objects as it relates to digital making with things that students may already have. We are providing lots of options for kids as it relates to accessibility. So I know in my district, we have a lot of kids that are fortunate to have access to internet, but that is not the case for every student. So just acknowledging this idea from a lens of equity that internet and supplies vary widely with our students. So the more we can kind of try to create options, create possibilities for differentiation and creativity, I think as we are going through farther with this distance learning experience is going to be what's best for kids. So let's see what else we have. Some questions. Does anyone else have any other lesson ideas or resources or other questions or thoughts in relation to this topic as we kind of wrap up?
I was just thinking about building at home, like with young people, and they might not. And I think someone alluded, or Katie, you had asked about how are people doing with technology, if they're distributing it, if they're not distributing it. And I was just thinking about like the opportunities that most students have a recycling bin at home, well, if they recycle, or a garbage can, and before things go in the garbage, they physically make, in that sense, with things, and then adding electronic components later on, just in the simple, like you can go to the dollar store and like little lights and LEDs and aluminum foil and create circuits, and then you're building with electronics in that sense. So if people can't afford going to buying a Raspberry Pi or a Makey Makey or a microbit, they can still create and build with those sort of things that they have at home. So that could be an interesting way of doing that. And so there's a website, Scrappy Circuits, I think the name of it is. We've got some really interesting project ideas to be able to create with those, and just like binder clips and aluminum foil and key lights, and boom, you've got like let's build electric circuits and stuff like that. So like putting that power back into their hands to be able to create.
Awesome. Yeah, I love the Scrappy Circuits. There's just some great ideas with some basic, inexpensive, everyday supplies. So that's really cool. Any other last minute thoughts before we kind of reconvene in our main meeting room? Thank you again for being here and contributing to the discussion. Hope you're able to kind of come away with some different ideas and resources. Feel free to reach out if you need anything. Today and beyond, we're just thankful for great participation in this event, and I think it's been a really awesome opportunity, considering that this was supposed to be an in-person conference. So this has been a lot of fun.
Thank you, everyone. Thank you, Rachel, for being our amazing host. Can we give Rachel a big round of applause?
And Katie.
Woo! Nice job. And thank you, everybody.
Yeah.
It's lovely being with you all today.
Yep, we'll see you back in the main room in just a few minutes, and we'll kind of wrap up our morning. Thanks, everyone.
Bye.